All right, guys. If you would please go to Microsoft Teams and download the folder that says DEM and Topo and the MBMG style at the bottom. If we get a chance, we'll go into the geology, but we'll download that if we get to it. I gave you a printout of the National Map Viewer handout, or Tyler did, and the introduction to rasters. We're going to talk about rasters today. And if you did your homework or have been coming to class regularly, you probably heard me talk about the two models. Raster and vector are the two models that GIS employs, and rasters are images, whereas shapefiles are vectors. Rasters have a lot more data in them than shapefiles do. So today we're going to take a look at rasters, and we're going to kind of go through the different types of rasters the same way we did the different types of shapefiles. So your handout actually walks you through downloading these from the web, but in the interest of time, I just downloaded them for you, and they're in that folder with today's date, the DEM and the topos. The geology, geology you can't get online right now, but if you're interested, I can tell you how to get it. And if you would please open up a new blank instance of ArcMap. We're just going to start from scratch today. I'm operating from a new folder on my desktop today. So if you're doing the same thing, you want to keep that name 121, make sure in catalog you connect to that folder wherever you're keeping it so that you can access those files. While that's downloading, I'm going to talk you through how we get these files. We're essentially going to go back to the same place we started to get the vector files. And if you don't know the website, the Montana State Library has a terrific resource for GIS data. So you can just Google Montana GIS, and chances are the state library is going to pop up. In this case, it's the second link. I just said GIS Montana. Now, where I sent you last class was the data list. So if we go into the data list, I'm going to expand it so you can see this column over on the left. What I'm looking for today are topographic maps. We're going to look at two different types of topographic maps. So if you click on that link, we get two different types here. We get individual TIFF files and we get Mr. SID images. We're going to look at these at two different scales. What I'm having you, or what I downloaded for you, or what I'm pretending to have you download today, is the 1 to 100,000 individual TIFF files. So at the scale of 1 to 100,000, we want individual TIFF files. And at the scale of 1 to 24,000, we're going to get the Mr. SID compressed images. And if you go to those links, you'll get a map that looks like each of these two on the first page of your handout. And you just click on the tile of the link that you want to download. In this case, I just gave them to you. In the topos, we have quite a few that start with F and a couple that start with S. The S are the Mr. SID files. You can recognize those because they usually have a SID extension. Those are continuous rasters. And these TIFF files are classified rasters. So let's start with the classified rasters. From Art Catalog, under topos, those are the ones that say F45 something. This is the designation of the location. It's at latitude 45, longitude 112, and then it's broken down into A through, I think, G, maybe H. But these are the 4 topo files that cover the Butte area. So if you'll just bring those into your map, you're going to get this message for each one saying we have an unknown spatial reference. You can check this box that says don't warn me again in this session, but don't ever check this box that says don't warn me again ever, because we're going to want to use that later. But for now, you can just ignore it. And bring those 4 files into your map. To look at all 4 of them at once, You can click on your little full extent logo and it'll zoom to all 4. So this is a classified raster, and what that means is this looks like an image to us. If you zoom in on it, it's just an image of a topographic map. It looks like an image, but it has been classified into different groups of colors. And that's done to compress the file and make it a lot easier to transport and just take up a lot less digital space. If you look at it, there's 255 colors here, but most of them are black. So what we're interested in doing today is actually compressing that further into really just 13 categories. I think it's even less than that. But we're going to manipulate this classified raster. Now, the first thing to notice is these white cuffs on the overlap on the boundaries. Depending on how you brought them in what order, you're going to have different cuffs. But these white cuffs are a result of this being a map that was actually produced by hand and then digitized. So these cuffs are the product of the map actually bringing in the white edges around the hand mapped map. And we want to get rid of that. So the first thing we're going to do is take a look at how to do that. And just like the shapefile, we've essentially made 255 overlapping categories that tell each pixel what color it should be. So if you zoom way in on your map and get into the pixelated zone, you can see it's actually just made up of pixels, and identify one of those pixels, it'll tell you the color. The color index is 4, in this case brown. Pick a green when the color index is 5, and you'll notice that corresponds to this over here. So we're essentially creating a polygon shapefile made up of zillions of little pixels. So this is a much more comprehensive file than the vector files we've used in the past. But it contains a whole lot more data than the vector files we've used in the past. It doesn't have an attribute table because your attributes are specifically these points. If you were doing an overlapping file, well, we'll come to the continuous rasters, and I'll explain this ARGB when we get to that. But for now, the first thing we want to do to make this look like a complete and continuous map is get rid of the white areas. How would you do that if this was a shapefile? Wrong answers only? I mean, anybody? Wild guess? Anything? Tyler knows. How would you get rid of the white? How would you get rid of the white on this? Oh, no, actually, in this case, it's a little easier than that. We're not going to clip it because this is similar to a shapefile, and this white is just basically a white area in the map. We can change that color. And instead of being white, we can say no color. And that makes the map seamless. Now, the trick is you have to do that with all 4 of these to make it completely seamless. But you can, with this type of map, manipulate these colors just like they're a shapefile and say no color on each of those white ones. And boom, your map is suddenly seamless and nobody can see those cuffs. So now we have 4 overlapping files, and by eliminating the white and basically just getting rid of that color, we can actually see the map in its entirety. But if we wanted to further simplify this and say we're doing the whole state of Montana, this is literally just the Butte area. I'll bring in Silverbow County from a previous class so you can see where we are. Let's see, I didn't link to it. But I can show you where we are exactly, and you can figure out how this falls. So we're really just operating in this small area here. But if we were looking at the entire state, we'd have probably 400 or 500 of these files, and we wouldn't want to do that with each one. So the classified raster gives us the option of creating what's called a color map. And the color map can be transferred from one file to the next. So we're going to create a color map with your first file, whichever one it is, it doesn't really matter. But what we want to do is we want to make this map act like a shapefile so we can overlay it on something else. If I wanted to put my Nape imagery in the background, there are 2 colors here that would obscure my Nape imagery. The green and the white are too continuous to overlap anything. And if we zoom in closely, you'll see that there's a lot of deviation in the colors. In places where it's supposed to be solid brown or solid blue, it's pale, it's a lighter color brown. There are grays where there should be blacks and stuff like that. And if we want to make this a little bit crisper image, we want to get rid of these pale colors. This is just a product of the digitization of this map. This number 8 pale blue is supposed to be the color, the corresponding color to 2. So we're going to change each one of these to actually match the ones that they're darker representatives. So let's go into each one of these the way you just did with the clear cuffs. Double click on that one, and instead of this pale blue fill color, click on more colors, and you get this option to actually automatically change your color. On the third page, I have the 5 different colors we want to change and the colors that they should correspond to. So the dark blue should change the pale blue to the dark blue, the pink to the red, the gray to the black, the pale lavender color to the purple, and the light brown to the dark brown, please. So in this case, I'm going to change it to 0, 151, 164. And that's the color that happens to match this number 2 blue. 0, 150, or I guess it's 163, not 164, but that doesn't, you're not even going to see that. Don't worry about that. I'm still hearing some clicking, but I don't know if that means you're onto something else if you're still working on it. Well, one more for me before we create the color map. Let's get rid of that green too, because we don't want to obscure the background. I'm going to bring in the Nape imagery. I don't want you to do this because it's going to bog your computer down, but I'll show you why we're doing this. When I bring the Nape imagery in, you'll see that it's obscured by the white and the green, and we've already nullified. Oh shoot, I didn't mean to do that. We've already nullified the white, but now we want to nullify the green. So nullify your green too, or set it to no color. Oh, I can't show you the Nape imagery yet because there's actually something I want to show you first, but we'll see it in a few minutes. I'm jumping ahead of myself, but I'll make that point in a moment. So you don't need to do this with all four, just with one. But once you've got that one changed, you can look at it and see that the colors are actually quite a bit crisper now and easier to follow. And if you wanted to put this on a background, it's easier to follow these lines. It's not perfect, of course. You've got some black in the blue and you'll see some red in the brown and that sort of thing, but you've got much cleaner lines in here for when you're actually trying to view this on a background. But what we want to do is apply this to all of our other files. And so to do that, we need to send this to a color map. So if you'll right click on the properties menu, or right click on the whichever one you colored and go into the properties menu, you'll notice the properties look a little bit different here. But under the symbology tab, all these lists of colors are here and it's listed as a color map. We want to create a color map that actually uses the colors we just created. So what we're going to do is export this color map. So if you click on that key that says color map under the symbology tab, say export color map, and you can save this, whatever name you want. I'm going to call it topo color. But keep that .clr because that's going to tell GIS that this is a color map. And just save that. Say okay. And if we exported that for this one, we're going to import it for the other three. So import that color map for your other three files. Your overall map should look like this, and you'll notice my cuffs came back. I don't know why. This is always a finicky problem with GIS. For whatever reason, when it exports the color map, it won't save the no color. So we have to reassign the properties to color is null on the white ones. If you just click on that white one, it'll get you a slightly different menu. But if you go to the properties tab, just say color is null on each of those, and it'll get rid of your cuffs again. So it's not perfect, but it's a whole lot easier than trying to do this for each one. And now we're back to having a continuous map without the green and the white for all four. And we can actually put something behind this. Before we go any further, I'm going to bring in the next type of raster, but let's take a look at this first. Open up your properties menu, and we'll basically do what we did with the vectors. Under the Generals tab, you have the same information you saw for vectors. You can scale it to see where you want to view it. You can add descriptions and credits and names and whatnot. Under the Source tab, you have the same information we saw before. You'll notice that the coordinate system in this case is undefined. We're going to deal with that in just a minute, but that's what's causing problems for me right now with the Nape Imagery not showing up. It doesn't know where this exists. The very first file you bring into your map, every time you open a map and bring a file in, the first file you bring in is what GIS assumes is the coordinate system you want to work in. This is your data frame. This layers menu right here, everything you put in here is going to show up in your data frame. And we'll talk about multiple data frames later, but for now it says layers, but this is your data frame, and you're viewing everything in the coordinate system of the first file you brought in. So I'm going to look at my properties here and see that my coordinate system has no coordinate system. Because the first file I brought in had no coordinate system, it was undefined, my data frame is undefined. So GIS can't do the on-the-fly projection where it automatically brings everything together for you. It will in a minute, but that's why it's not showing the Nape imagery here. It doesn't know where these files exist. So we'll talk about that in a moment, but back into the properties menu. You'll see that that's undefined, and we'll talk about how to do that. There's really no metadata assigned to this, but this is really important. Your metadata is where all of your information for this file is going to come from. Who built it? How did they build it? What scale did they build it at? All of the errors that went into it, who you need to cite as the author of this file. That will be in your metadata. It's not showing up for this file in here, but where you originally downloaded your file from, there's usually a metadata download that you can get. Your extent, just like the vectors, there's a box around this file, and the extent is within whatever coordinate system it is. These are the coordinates of that extent. Your display, here you can set your transparency and your contrast and all of that. We're not going to get into much of this other than the transparency, but if you want this to be semi-visible so that something can show through it or overlay it with something, you can do that here. Your symbology here, we'll play with this for a minute. You can actually change this and look for a different symbologies here. I'm going to make all these up because we can come back and reassign that color map now that we've done it, but you can assign random numbers. Assigning unique values here actually categorize those in a lot narrower range, so that actually is pretty helpful, but you can change that color scale as well to completely change the look of your map. You can classify them into gray colors or any color ramp you want. You can stretch the colors and this would turn this into a more continuous looking map, but it does not make it a continuous raster. In this case, it just turns it all black. We can go back to that color map where you can set up discrete colors, and it'll pick of those 255 categories, it'll actually assign everything from 0 to 255. Well, I guess it's only going to go blue with this one. But going back to the color map, because we created one, we can re-import that color map and come back to the way we want to view it. And there's a million reasons why you would want to do this differently in different colors. We're probably not going to get into anything crazy like that this semester. But the advantage of this type of raster is that it's a really small file. It's easily transportable, and it's very easy to make this turn into something you can overlay on something else. You don't have that ability with the continuous rasters. So the next ones I'm going to have you bring in, you can go ahead and uncheck these, but don't remove them from your map. We're going to come back to them. Let's bring in the continuous rasters, which are the S files, the Mr. Sid files, 62, 63, 72, or 73, and 74. So Mr. Sid images are much bigger images, where in the case of the classified raster, we have one color between 0 and 255. In this case, we have 3 bands that are each 0 to 255. So automatically, this is 3 times the size of the previous file, even though it's showing essentially the same thing. Now because, oh, I turned that. Because this is not a classified raster, we can't turn off the white and the green areas in this one. There are too many varying colors that make up the white and the green. Looking at the properties menu here, it's not showing the alpha band, but showing the red, green, and blue band. Each one of these is 0 to 255. And if you turn one off or uncheck one, it radically alters the way you see your image. Because what this is doing is each individual pixel, instead of being assigned a single color, each individual pixel is assigned a number between 1 and 255 for red, for green, and for blue. Think of this like a printer. If you're printing a color image on a printer, you put in your black ink, your magenta, your yellow, and your cayenne ink. And all 3 of those come together and they mix the colors to make the color that you see. So if you take one of those inks out, you get this warped color. That's essentially what GIS is doing here. So it's applying these red, green, and blue bands to make the image appear this way. And the advantage is this is a really continuous file. It's very seamless. If you zoom in on it, it's a much higher quality image, but it takes up a ton of space and you can't put anything underneath this and make it visible. So just play with the different types of ways to display this for a minute. You've got a lot of information you can play with in here. You can actually change the standard deviations. Let me zoom back out to the file so you can actually see this changing in the background. But playing with the different ways you can display this gives you all kinds of information. You can actually set these up in the same way we set up we can actually set up individual colors for this, but you're never going to match the number of colors simply because you're limited. 255 times 255 times 255 is considerably higher in the color range than just the 255 colors we have. But play around with this just for a minute and look at the different ways you can view this. You can apply a gamma stretch. I mean, there's all kinds of stuff you can do with this. You can even adjust the red, green, and blue. Under stretched, you'll see there's this use hill shade effect. You can turn that one on. Hill shade effect, and we're going to use that in a minute. Hill shade effect actually takes your image, looks at the elevations in it, and then tries to apply a shadow to it to make it look like topography. So these are actually topographic maps, but they don't have topography applied to them. So this kind of gives it a way to look like topography, even though it's not. Play around with those for a minute, but then come back to RGB composite and make sure your stretch type is set to none to make it look the way it originally started. Under the Display tab, there's this checkbox, Display Raster Resolution in the table of contents. This is the scale at which this raster was developed and how accurate this raster is. So we're displaying that if we turn that on. It's not going to mean much to most people, but be aware that it's there. Okay, let's go on to the next file. These, you can say okay, we can uncheck these and keep them in your map, but just uncheck them for now. Now I'd like you to bring in the DEM. Make sure you grab this one that says FLT, floating DEM, not the thumb, but this image right here, this little graphic that you saw on the other ones, indicates that this is a raster file to GIS. So just like we have shape files that are polygons and line files and point files, this indicates a raster. So let's go ahead and bring that DEM in. Okay, here is where, oh, I lost my mouse. Here is where we get into trouble because we don't have a coordinate system assigned. When I brought the DEM into my map, nothing happened. It's checked and it's in there somewhere. But if I zoom to that layer, I can see it's actually in my map, but it's not showing up where I want it to be. I'm gonna remove this for now so I can zoom to layers. So if I zoom to my full extent, boy, they're so tiny I can't even see. I don't even think they're, oh no, there they are. I can't see my DEM on here, but it's in there. The problem is my DEM under the source tab has a coordinate system, GCS North American 1983. So GIS knows where this exists because it has a coordinate system. It doesn't know where these files exist because they don't have coordinate systems. Or no, this one does. This one actually does. So the trick here is that the data frame doesn't have a coordinate system, and we have to assign it in order to bring all of these files together. In order to make them all appear in the same place, we need to assign a coordinate system. So go ahead and check everything. These two are appearing in approximately the same place, but the DEM is not. And what we want to do is get GIS to do that on the fly projection and bring all three of our files together, the DEM, the Mr. Sid files, and the TIFF files. So right click on layers and go to properties. Go into your coordinate system tab. And we're going to assign a coordinate system to the entire data frame. Select geographic coordinate systems. Scroll down to world, and at the bottom of world, you've got WGS 1984, not with anything after it, just WGS 1984. And before you double click on that, I would like for you to just highlight it so that it's lit up in blue and go up to this little star and click on that star. Now, this has added this to your favorites menu. So if I close this out, the next time I want to assign something, a property, if I want to go in there and look at my coordinate system, I don't have to hunt for it. It's going to show up at the top under my favorites menu. So if you don't want to go hunting for something, that makes your life a little bit easier. We're going to populate this with a few different coordinate systems, but for now, let's just use WGS 84. If you double click on that, it's going to bring up this menu that wants to give you control over changing exactly how that works, and it makes it a custom coordinate system. Just hit cancel and ignore that. We just want to click on it once and say, okay. You're going to get this warning that says that's doing transformations to make everything work. Yes, for now we want it to do that. Oh, well, that's not good. All right, sorry guys. Give me a second to pull all that back up. That's why you save often, Mary. Okay, so this is what it was supposed to do. It was supposed to make them come together and appear in the same place. It looks like this one didn't come in though. I'm just not showing up. Okay, we might have to take an additional step because these are not showing up where I thought they were going to show up. Yep, they're off in space somewhere. So we're going to take an additional step and essentially do the same thing. This is not on your handout. So if you want me to do this really slow so you can take notes on it, this is something we're going to do repeatedly through this class. So your F46112 and 113 files, please don't crash again. They still don't have a coordinate system assigned, so we're going to give them a coordinate system. Now, because I downloaded these and I assumed the world file is what tells it what coordinate system it's in. I downloaded these and I knew that the world file wasn't coming, but I thought it was still attached to the file. I'm going back to where I downloaded these from to look and see what coordinate system they're in. I downloaded the individual TIFF files and it says in UTM or state plane coordinates. So that doesn't mean anything to you yet. We will talk about that, but it tells me that I need to assign the coordinate system to be either universal transverse Mercator or state plane. And it's almost always in meters. So we're going to guess at this and we'll figure out which one it is as soon as my computer starts cooperating. I'm probably trying to run too many things and it's freaking it out. All right, so what we want to do is actually operate from ARC catalog in this case. The topo files that don't have a coordinate system are these F files, and they're undefined, but you'll see the extent actually has coordinates in them. So when you open up that source tab, you'll see those coordinates and it says the extent. What it doesn't understand is what those numbers mean because it doesn't know what coordinate system it's in. So if you'll go into your ARC catalog and just pick the first one in the list, F45112E1, right click and go down to properties. We are going to change this spatial reference. And actually, you guys are good. I'm going to put this in the map to make sure it moves when I do this. And go back to assigning this WGS84 so I can see it. So what we want to do is go down to properties, turn that on, and it says here next to undefined spatial reference, edit. There's an edit button. So click that edit button, and this time we're not going to go into geographic coordinate systems. We're going to go into projected coordinate systems. So expand projected coordinate systems, and it told us that our file was either state plane or UTM. So we're going to try and guess which one it is. This might take 3 guesses, but we'll hope for the first one. So open up state plane, go into and scroll down to the folder that says NAD 1983 meters with nothing else after it, just NAD 1983 meters, and expand that and scroll down through that list until you see Montana. And select Montana. You can hit apply and then OK. And hopefully that will show up in Silverbow County. Let me make sure I got that one right. The only way to check that is to use something that you have a defined coordinate system for. And we know that the Montana counties was correct. So let's see if it overlaps Montana counties. It doesn't look like it did, so I think I probably got the coordinate system wrong. Oh, no, it did. Okay, so that is the coordinate system we wanted. All right, so if you were thinking ahead and I wasn't, you saved that coordinate system as a favorite. But if you didn't, we'll go through that again. So on the next one down the list, F45113E, click Edit on that undefined, projected coordinate systems, state plane, NAD 1983 meters, and scroll down until you see Montana, but instead of clicking on Montana, or instead of just choosing it and saying okay, be sure to hit that little star and add that to your favorites. So this is NAD 1983 State Plane Montana meters. And we want to add that to our favorites. So now we have 2 favorites. We don't have to go hunting for that every time and say okay. Do that for the other two files as well. Bless you. It's a little easier when you don't have to hunt through the list for it. And now, these should come together where they're supposed to in Silverboe County. Now, I'm just, while you guys are doing that, I'm going to get caught up here and get rid of the, reassign my color maps and get rid of the cuffs so that I can be where I was with the other one. So just bear with me one moment. And I will get back to where we were. Okay, so this is back where we were. Now I'm going to bring in the Mr. Sid files. And your map should look something like this at this point. Your data frame is assigned to WGS 1984. Your Mr. Sid files have the coordinate system NAD 1983 state plane meters. And your TIFF files now have the coordinate system NAD 1983 state plane meters. If your map didn't crash and they didn't show up after you made this change, and there's just still hovering somewhere off in space, hit this little refresh button down here and they'll jump into place. They should all three blend together at that point. Oh, I need the DEM as well. So your DEM should also be in the same general vicinity as Silverboe County. I didn't get the entire Silverboe County because I'd have to do some data processing, which we will do. You're going to get to do it for homework. But now we should have all of our files in the same place. So although we're operating in at least two different coordinate systems, maybe three, let's see what the DEM is. Yeah, the DEM is in GCS North American 1983. So the DEM is in GCS 83. Our topographic files are in state plane meters, and our data frame is in WGS. So we've got three different coordinate systems going on here, but they're all overlapping because GIS knows that's where they all exist. So this is called on-the-fly projection. Now back to the DEM. Because the DEM is a stretched image, and what this is, the DEM is a digital elevation model if you're not familiar with them. Each pixel in this case represents an elevation, in this case meters, from 1,311.07 to 3,379.39. These are surveyed elevations for these locations. If you zoom in on this DEM really close, hopefully we can get it pixelated. I mean, I don't know if you guys can see it on the screen, but might pick a better place, but you can get the pixels if you choose your little info icon and click on it. It'll tell you what each cell elevation is. Well, it'll give you all kinds of information, but what we're really interested in is this pixel value. I happen to click on an elevation of 213.539307. That's the elevation at that location. So zooming back out, my digital elevation model is another representation of elevation in addition to topography, but my elevation actually can show me a better representation of the elevation. So what we want to do to bring this together is go into the symbology of the DEM and click this Use Hillshade effect. Check that box and say okay. Now turn off or uncheck your Mr. Sid images because we want just the DEM and the TIFF images. And I'm going to put the DEM on the bottom. If you want to zoom in on your DEM, once you've done that hillshade, scroll in and look at it. It actually looks like topography now. You can see where the mountains are. It's applied basically a color or a sunlight direction to it. It's applied an aspect to make this look like topography. The advantage we have in using this with this classified raster is that we can actually overlap these two and make this look like, this map actually look like topography with the topographic lines overlaid. We can't do that with these Mr. Sid images. They don't overlay. You can set them to semi-transparent, but you'll never get that same very clean, clear kind of view of it. Let's see. I'm going to set my transparency to 50%. So if I uncheck these rasters, you get a similar looking map, but it's not quite as clean and clear. But maybe that's what you're looking for. It's going to be a lot harder to read the text on this type of map, but the two different ways of displaying elevation, the two different rasters working in conjunction actually present your map very differently. So you have these different options with the different types of rasters. Oh, I need to talk about arc seconds. Let's see, I think your DEM is presented in arc seconds. Okay, so when we download maps from the web, I'm going to go to the National Map Viewer now. This is another place you can get a lot of data. The National Map Viewer is, or TNM, is actually pretty terrific. It's from the USGS, and it's an interactive map of the entire United States. You can zoom in on an area and pick out what you want. This is actually where your DEM data came from. I downloaded that for you, but I downloaded, I believe, 1/3 arc second DEM data for that. So if you zoom in and you just kind of look at this, the data products, it'll tell you what's available. 1/9 arc second probably isn't available very many places, but if you zoom in on this map, it'll tell you what's available and you can choose what products you want. I gave you a handout on how to, what the National Map Viewer will send you, but I'm not going to spend a whole lot of time with this. Basically, you can get the type of map you want, whether you want it in a file geodatabase, a shapefile, or a GeoTIFF image, which is a raster. However you want to do this, you can download these different types of data. And in this case, paying attention to arc seconds is really, really important. Your arc second tells you what the data density is. 1/9 arc second is really small data. It's not going to be available in a lot of places still, but 1 arc second is essentially 1/3600th of a latitude or of a longitude line. Because we are high up in latitude, we're at around the 45th parallel in Montana, we're actually in a place where the longitude lines are starting to converge. If you think about how the longitude lines are drawn, they come together at the poles. So they are exactly 1 arc second apart at all places, but they are also a different distance by foot or meter or whatever measurement. Does that make sense? So at the equator and the prime meridian, we have I think it's 30 meters. 1 arc second is 30 meters at the equator. But the further away from the equator we get, the closer those longitude lines come together, so the more that changes. In the case of a 1/3 arc second, we should have, if we were sitting at the equator, we should have 10-meter DEMs. So we should be looking at a cell size where each of those cells and each of those elevations is 10 meters. But in this case, because we're so far north, it's actually 9.23 by 9.23. You guys following what I'm talking about here? Everybody's just kind of quiet today. Okay, so when you're looking at an arc second, The higher the fraction, the denser your data. 1/9 is great if you can find it. 1 arcsecond is so huge it's not going to tell you much, and it doesn't look very good in hillshade. We are actually going to do something with that later on, but that's something to be aware of. How you get your data and what it says is pretty important. So I'm actually going to uncheck all of this, and we'll go into the geology now. The geology is not on your handout because this is effectively just something that's released by the State Geological Survey to well, it's available to my department, but this is a really great way to see how people present their data. If you'll bring in Butte Geology and Butte faults, they'll come into your map and just zoom to those layers. They'll come into your map looking like not much. Now in this case, it's randomly assigning a color because this is a polygon, but there is a color map out there that is specific to the way this map was published. Somebody released a color map to make this view the way you want to see it. You put your faults on top of your geology so you can actually see them. So go into the properties menu for Butte Geology. Under symbology, we're going to go into categories. And just like we did with the raster, instead of being called a color map, this time it's called a style. So we're going to click this match to a symbols in a style. And the value field we're interested in is not area. I'm going to open this real quick and show you in the attribute table. It's usually some crazy code, that won't make any sense to you whatsoever, but you should look at the attribute table to see what that is. In this case, these are the geologic unit names. So what we're using is the geologic code to classify this. So under the properties menu, we're going to match to a style, and we want to look at the MBMG code. The style, you're going to have to find the style. So browse to the mbmg.style link I gave you and say open. Now it's not reading anything yet. It knows you want to match a style, but it doesn't know which ones you want to use. So just say match symbols and it'll grab all of them. It should populate your list with the exact same colors I have here, and you can uncheck all values. Hit apply, and if any of you have wandered the halls upstairs, you've probably seen a map that looks like this and has these colors. It's a lot more uniform in eastern Montana, but we're so broken up over here. We've got a lot of geology over here. But this is the published geologic map that is universal for Montana. You don't have to assign your own colors because it has been created as essentially a color map, but because this is a shapefile, they call it a style. Now the same thing goes for the faults. If you open the attribute table on the faults, you'll see this time instead of MBMG code, it's called ARC code, but this is identifying what type of fault it is. So right-click properties, symbology, match to a style. We want to use ARC code. Again, browse to that same MBMG style. Match symbols. Uncheck the all other values. As you can see, there aren't any all other values anyway, so we don't need it. But this tells you what type of fault it is, and it actually displays it using the USGS designation for that type of fault. Apply and OK. And you just created the geologic map for the Butte area of Montana, exactly as it's published and as the USGS recognizes it. So this is Butte North, but if you're interested, there's also Butte South. You can do the exact same thing and bring that area in to create a seamless map of Silver Bow County. And all of the geology of Silver Bow County. So this is effectively your introduction to rasters. I haven't heard any questions today. You guys are awfully quiet tonight, but I don't have anything else to show you. Are there any questions about rasters or about topographic maps? Because I am going to give you another homework using rasters. No? You're all squared away, so if I asked you to go repeat this assignment, you could do it on your own? Okay. Yes, no, maybe? All right. Well, I am going to, I am recording the lectures now on Zoom, and I'm putting them on YouTube now that we've got that figured out. So I'm going to send you around a link to YouTube if you'd like to follow this. If I am going too fast for you, please stop me. Ashley's not here tonight to slow me down, so you know, if you have a question, don't hesitate to ask in the middle of class. If you have a question later, don't hesitate to call or email. But that's all I have for you tonight. That's your introduction to rasters. You've now looked at rasters and vectors, the two types of files that really are the heart of GIS. Okay, all right. Go forth and do good work.